But different than most of the other topics we've been covering. I changed the title to be actually a bit more descriptive. This is a project that's been supported by the California Dairy Research Foundation and sponsors Nestle and Hilmar as part of their sustainability programs for sustainable sourcing of milk. And you can see we have quite a few cooperators, Peter Robinson from Animal Science, Gene Axland from Agronomic Services, and Nick, who just gave the previous talk. Beets have a long history of production in California. Actually, the first commercial sugar beet factory in the U.S. was built down near San Jose in 1870. And there have been 11 factories built and operated around the state over that time. Only one still is operating in the Imperial Valley. But the first one was down there in the San Jose area. And in fact, I'll give you a little secret. The Silicon Valley used to be called the Sugar Cone Valley. Not many people know that, but now you do. So there's an opportunity to grow sugar beet, again, in the Central Valley, since these factories have closed and there's no longer a sugar beet industry there, but only as a winter crop. That's the official UC recommendation, my recommendation. Why beets? Well, they're salt tolerant, they're deep-rooted, and they're well adapted to the valley's climate. They help to diversify rotations, and they provide alternative enterprises and flexibility for growers. They can be grown during the fall to early summer period where you have the most maximum water use efficiency. There's no irrigation system you can use that improves water use efficiency as much as growing a crop in the winter compared to growing it in the summer. And yields have been increasing steadily, and they're the highest in the world in California. So there's a lot of opportunity. This is data from yield trials in the Imperial Valley for variety trials. And you can see that in recent years, the highest varieties for a long season crop, somewhat similar, fall planted and summer harvested in the Imperial Valley are pushing 80 tons an acre. Actually, a grower produced 89 tons per acre in a field a couple of years ago in July. So their actual yields are quite high. I'm not going to really talk about sugar beet agronomy because really we're talking about how the trial that we conducted last year on a dairy farm where we actually grew them and fed them to dairy cows. But there's a lot of advantages that I want to point out again for fall and winter production. Planting in fall makes it relatively easy to have good stand establishment. And if you harvest by early summer, you avoid most of the significant pests and diseases that sugar beets can get, especially when they're grown in the hot weather. So it's really a very sensible thing to think about. This is old data for water use by sugar beets. And you see a lot of numbers out there, but it really depends on the season of the year that you grow it. If you start in October and harvest by June, it's roughly 2 acre-feet of ET for a sugar beet crop. If you do it the opposite, if you plant it in spring and you harvest it in fall, you may be looking at double that amount for the same dry matter. This is an old slide that I use all the time. It shows that beets are a deep-rooted crop. And this is work that we, next to it is a graph that we did at UC Westside Research and Extension Center on, of course, a Panoche soil, which is a deep soil. And it shows the amount of soil moisture by depth down to 9 feet. This is in, I think, May. And this was in July by the time the crop was harvested. And you can see depletion down to 9 feet by the beet crop after a long season. So there's an opportunity for a crop like this to actually recover water that might be missed by a corn silage crop, and also potentially the nutrients that might be tracked with that water. This is some additional work from that same, and you can see the ET, this is in millimeters. So this is about 2 to 2.5 acre-feet of water for maximum root dry matter yield. This is an unfortunately metric system, but in June. It gets higher, of course, if you go as long as July, but we're thinking that you'll be best off sometime around this period of time at 2 to 2.5 acre-feet of actual water use. And this is on a sugar basis, but it's also true for dry matter. This is the ratio of applied water to the amount of ET. And by June, if you're putting on about 70% of the actual ET of the crop, the beet does just fine. In other words, it's recovering water from the profile in addition to what was applied. So it just reinforces that particular characteristic of the crop, that it's deep-rooted and is able to forage at depth. What about salinity? Beets are among the most salt-tolerant crops that you can grow. It's up in the range with cotton and barley. So they're really, there are some sugar beets, believe it or not, in this. You can see all the gyp on the soil surface here in the western San Joaquin Valley. That's not necessarily the best conditions for sugar beets. This is a trial that we did down in Imperial Valley a few years ago where we actually tracked soil salinity and root yield spatially. You can see soils that had a decisemen of around 10 to 12 decisiemens here. And this was 1 to 2 to 3 to 4 decisiemens. So the range went from 50 tons to 26 tons, but there were 26 tons in the very salty ground. So they actually yielded well there. You can see this is again the sugar yield curve versus ECE to about 4 to 5 feet. And you can see that there's practically no effect up to about 10 to 12 decisiemens. So they're really quite salt tolerant. We know that when you're putting manure on in your dairy farm, you have almost as much salt or about as much salt as nitrogen in manure. So over time, there's quite a bit of salt that gets applied to fields as manure. And if you have a soil condition that tends to accumulate salts or has accumulated salts over time, this is an alternative for you and won't have any really deleterious effects on yield. So we strip-tilled beets at the end of October last year into dairy soil that had lots of manure. We got really excellent emergence from that strip-tilled system, which is about 65% of the beets planted and about 2.5 beets per foot, which was almost ideal. In fact, I'd say it is ideal. Beets were and are Roundup ready for the most part nowadays, and Roundup was the sole weed control material used, and it worked very well. You can see around just before Christmas what the beet rows looked like, starting with essentially beginning of November planting date. This was mid-January. We had about a 6.5 acre plot. That's that large area there. It was planted with equipment from the farm. And there's a canopy in April, about a month before harvest. So it was quite vigorous. Beets did quite well. We hand sampled a number of places to collect hand samples prior to digging the field. And these were we had 2 varieties, a beta seed variety and a holly seed variety. This is tons fresh weight per acre. There's the variance around the field. So they varied from about 52 to 65 tons per acre of fresh roots, which is really an excellent yield on this ground. So it's really very productive. And the tops, there's quite a bit of fresh material as tops. You can see, again, tons fresh weight per acre between 13 and 20 tons of fresh weight material per acre. Now, there's a lower dry matter in tops than in roots. Roots are about 25%, 25% dry matter. Tops are somewhat less. These were the yields. You can see that for the field average and the 2 varieties, top and root fresh weight harvests, and they varied from about 60 to a little bit closer to 80 tons, because the holly variety was very leafy and the beta variety was not very leafy. This is breaking it down. This is the root weight separately, and this is the top weight separately by variety. So it's the same data, just expressed a little differently. We didn't have a good digger. This is my digger. It's 2 years. It's a 2-row digger. It might be as old, if not older, than I am. But we managed to make it work on 6.5 acres. One of the things, the current dairy provider, we've made arrangements for commercial digger. So this was a bit ad hoc, the harvest, and so it took a little bit of time. Did a reasonable job harvesting the beets, but that's one of the barriers that has to be overcome, is how do you actually harvest and transport the crop. This is being done commercially on dairies in the Phoenix area. So they've made that adaptation using commercial sugar beet digging equipment and modified forage wagons. So it can be done. I wanted to put this up because we're going to talk now about the quality of the roots. Sugar beets are an interesting crop because they have essentially no lignin. So that means all of the fiber, which is largely pectin, hemicellulose, and cellulose, is digestible fiber, and it's known to improve rumen function. It's highly digestible, but improves rumen function. And of course, there's lots of sugar in beets. Typically 15 to 20% of it is sucrose. So there's lots of energy. This is a high energy, highly digestible feed that fed the right way improves rumen function. So here you have some of the initial quality characteristics. You see dry matter, ash-free NDF. You see ash totals, and total N, P, and K. This is on a dry matter basis. And nitrates. Nitrates are a little high for dairy feed, but they disappeared during the ensiling process, or at least were reduced. This is, I think, the leaves and tops, and you can see that's the, the leaves are actually fairly high in protein. Again, fairly digestible, low NDF values, but actually very high nitrate levels. Of course, all that nutrients that have been put on over the years with manure show up in the field and get absorbed in the leaves of beets. It's like Swiss chard or spinach, so it absorbs quite a bit. So if you're going to feed these materials, they have to be fed with mindfulness that the leaves particularly are high in nitrates. Now, beets are 20 to 25% moisture, so that means when you ensile them, a lot of moisture comes out, and that moisture is full of sugar. So we decided to co-ensile the beets with about 40% by weight of almond hulls. Almond hulls are a common feed in the valley. They're quite available. They're an excellent feed in their own right, and the almond hulls absorb some of the leakage from the beets. And they were basically put in an ag bag, and they were mixed right in the front of the ag bag. And as the bag was filled, it was mixed, and it mixed pretty thoroughly and pretty well. Worked actually pretty well. And this is what that feed looks like as fed. You can still see the almond hulls intact, and the beet roots more or less broken down. Now, the moisture that the almond hulls absorb makes them more palatable, more easily digestible, and higher in energy. So it actually improves the quality of the almond hulls as a feed. It adds value to the almond hulls. Plus, you have the value of the residual beet material. We did samples. Peter Robinson did this work all through the bag itself. And this is some of the data. Fermentation temperatures were quite good. Fermentation went really well. There were no particular problems or difficulties with fermentation. Density was more or less uniform across the bag. Almost all these characteristics are reasonable for silage materials. The volatile fatty acids that were found in the bag were again indicated good quality. You didn't have any of the ones that you wouldn't want to have, like butyric and so on. And there was very little ethanol in the system, indicating again no particular difficulties with fermentation. This is some analysis from some of the beet almond hull silage itself. You can see ash, crude protein, ammonia. Nitrates were much lower. Remember, went in at around 2,000 parts per million and came out below 1,000, which is the threshold for concern. NDF is quite low. Water-soluble carbohydrates are fairly high. And net energy for lactation is somewhat less than corn silage, partly because of the almond hulls affected. If it were just beets alone, it would be would be higher. But the mixture turned out to be quite a high quality feed. You can't really directly compare it with corn silage because it has different digestibility characteristics and other and when you do total mixed ration balancing, what you get is you have to meet certain fiber, energy, and protein requirements, also other secondary characteristics. And you can meet them in any number of combinations of ways. And so when you change one major feed input, it changes the value, the uses of all the others. So we still have actually a lot of interesting work to do to see how these kinds of feeds might actually fit into dairies. What? Oh, I'm in time. I'm good. But they fed really quite well, and they have characteristics that indicate that they're going to be a high quality material. And when you think about them filling the production role in the winter period, and then you combine that with corn silage, if you're thinking about the efficient use of water, to generate highly digestible feed per unit of water, the combination of those two crops are probably going to work out to help dairymen partly weather some of the water constraints they're going to have. Now, these are economic costs from the dairy to start off. These are the operational costs. They estimated somewhere around $540 per I think this is per, what is, we have this on the base, per acre to produce that crop. And if you add all the accounting costs up to about $760 per acre to produce it. Glyphosate, they had 3 applications. If they had used the one variety, the holly variety, probably could have gotten away with 2. They applied about 30 acre inches of water. I think they could have applied less. It was all lagoon water. And their total operating cost was around $760 an acre for that roughly 60 tons of beets per acre that they produced, which is roughly 12 tons of dry matter. And these were the costs. This is just a table that was created calculating the root yield of beets, the cost per ton of beets based on that $760 figure. And if you bagged with almond hulls, roughly about $35 per ton worth of almond hulls of final silage, you ended up with feed costs of around $48, a little bit less than $50 per ton. So we still have a lot of work to do to figure out the true economic value of beets as a silage crop. But as a fall to spring, early summer crop, it has a lot of promise, and especially given its high nutritional characteristics, it may help dairymen have a few more tools in the bag as they try to deal with reduced water supplies in the future and a need to better manage nitrates, especially at depth in the soil profile. So, in summary, I think that this is a good opportunity to pursue a novel alternative crop for the dairy system. I think we need to be thinking about other crops as well. We have a trial actually with safflower as a fall planted crop. There's no deeper rooted crop than safflower made of silage, so we've got that underway as well. And as I mentioned, these characteristics look very promising based on this 1 year's trial. So we have another trial going on in a different dairy this winter, the Wilbur Dairy down near Tulare, and hope to have more data for you perhaps next year about that. So thank you.